That'd be a good thumbnail. I gotta switch the screen because you guys are gonna become too small. Okay. Oops, my bad. Limit as x approach infinity of c over x to the r. R as any power is greater than 0. This one is always equal to what? C is some type of constant. It doesn't matter what constant is. X to some type of positive power. It doesn't matter what kind of power it is. What is, if x approaches infinity, this function is going to be what? Why do you say 0?
It's going to be divided by bigger numbers.
Right, because if you have, just say even the number is 9 billion on the top. I don't know how many zeros 9 billions. How many zeros is that?
At least 8.
9 billions, right?
Help me out with the number. Keep my survivability. See, you don't know me that, and I'm not getting there laughing.
So those are 9 zeros, I think. Is that right?
Yeah. No, there's 8. Wait, 9 billion? No, yeah, no, it's not. That's wrong.
Is that right?
Yeah, that's right.
Are you sure? Okay, I don't know. I don't know my numbers.
We can
I'm only calculus teacher. I don't know my numbers. So let's just say over x, when limits x approach to infinity, it doesn't matter what the numerator. If the numerator is a number, infinity is always going to overtake 9 billions. It could be 99 billions. It could be anything. So if you compare 9 billion to among the sand in this world, right? Among the pieces of sand, that there's no comparison because it's going to be infinite amount. It's almost infinite because it's so large that 9 billion cannot compare to, right? So it doesn't matter as long as x on the denominator and numerator doesn't matter what number is it, it's always going to go towards 0. So it's always going towards 0, regardless of what happened. It could be square root of x. It's still going to go to 0, as long as x to the positive power. Even x to the 0.1 power is still going to go to 0. So long as r is greater than 0. If r is less than 0, it's going to be flipped, right? If r is -1, then the x is going to go to the numerator, then that's going to go to infinite. But the problem is if you have x to the r. It doesn't matter if you reach negative infinity, it's still going to be the same way because c over x to the r is still going to go to 0, but it's in different directions. Now that's something that we did. Okay, so we're going to talk about 2 things today. We're going to talk about when limit x approaches infinity. Also, we're going to talk about something called horizontal asymptote. Horizontal asymptote is, whatever. Anyway, so if you have limits x approach to infinity of 2x cubed plus x, 2x squared, sorry, 2x squared plus x, let me see what is it. I'm just going to copy and paste because I do like this question. Copy. Paste. Okay. I have limit x approaching infinity of 2x squared plus 3x minus 1 over 5x squared plus 3x minus 1. Now, some of you guys probably don't know what this is. Now, this is the same questions asking you, what is a horizontal asymptote of 2x squared plus 3x minus 1 over 5x squared plus 3x minus 1? Do you guys know what is a horizontal asymptote in this particular case? Nathan,
Is it 2/5?
why do you say it's 2/5? Devin, what were you gonna say?
Yeah, I was gonna say 2/5.
Okay. All right, Madden and Devin, good job for listening from Mr. Shapiro, because he probably told you that. As you look at the degrees of a function, if they have the same degree, you look at the coefficient of the highest degree. In this case, x squared is the highest degree, therefore it's 2/5. Very, very good job. So then you're in calculus now. We're not gonna study the degree stuff. We want you to understand it. Okay. So when you ever have this case, you're gonna look at the highest degree of the denominator. What is the highest degree of the denominator? Highest degree is 2, x squared, right? Now what I'm gonna do is I'm gonna ask you to do math. What kind of math are you gonna do? You're gonna divide by numerator and denominator by the highest degree of this. So when you divide everything, so it's gonna be limits. So I'm gonna just write down equations. X approach infinity is equal to 2x squared plus 3x minus 1 all over 5x squared plus 3x minus 1. And I'm gonna divide it by x squared. I'm gonna divide by everything by x squared though, not just only one thing. I'm gonna divide by everything by x squared. What's the nice thing is, due to exponent rule, this is gonna cancel out. Yes.
So when we do this, you only take the highest degree of the denominator.
And you divide it by everything by the highest degree of denominator. Not the numerator, only in the denominator.
Oh,
So in this case, it's x squared. I'm gonna divide by everything by x squared, and then everything is simplified down. Now you should see something. What is the limit x approach infinity of 2? It's just 2, because just like the one with pi question that on the test, limit x approach pi on pi is still pi. It doesn't matter if you reach infinity or pi or x or 3 or whatever. It's just going to 2. It's not simplified. Now what happened when limit x approach infinity of 3 over x?
0.
So it's 2/5, right? So the answer is 2/5. Now, does it matter if I reach negative infinity or positive infinity? It actually doesn't matter in this particular case. If I approach negative infinity, it's going to be the same thing. It's going to be 2x squared plus 3x minus 1 over 5x squared plus 3x minus 1. I'm still divided by highest degree of denominator. But if I reach negative infinity, does it matter? Well, limits x approach negative infinity of 2 plus 3 over x minus 1 over x squared over 5 plus 3 over x, 3 over x minus 1 over x squared. If I reach negative infinity, for example, if you have 1 over 10, 1 over 100, 1 over 1,000, right? That's going to be 0.1, 0.01, 0.001. It reached past infinity. It's going towards 0. Does that make sense? Now, what if it reached negative infinity? Negative 10 is negative 0.1. 1 over negative 100 is negative 0.01. And 1 over negative 1,000 is going to be 0.01. But it's negative. But still going to what? It's going to a 0 regardless. So this is 0, this is 0, this is 0, this is 0. So it's still 2/5. So it turns out there was a 1 horizontal asymptote, which is 2/5. And guess what? Let's check the graph. Does everybody understand this part? Or if you don't understand? Mia, do you understand? You sure? You can ask question. You okay? Be strong. Don't worry. Ask questions. Natalie, you okay? You okay? Martin? Al? Devin? You can ask. What's your question, Devin?
Why is it equal 0? Like all the other.
Because group leader, can you explain to him why is it equal to 0?
What do you mean? Just because it's approaching 0?
It's not approaching 0, it's approaching negative infinity.
Yeah. Oh, okay. So just wait. So it's just back to like this. Where it's like, see how you're gonna get to 0 like this number is. Gonna be like closer to 0 because like let's say that C is like 1 and then next like 2 and then
Sven, do you
R,
understand?
The more that R
Armin?
is, or the more that
Yeah.
X is, it's just gonna keep going. Because if it's like X is 2, then it's gonna be.
Now, I'm going to say something very controversial. I'm a big fan of controversial. Wait, didn't Florida pass a law says don't say gay, Bill? What, you're not allowed to say gay? What does that mean? What does the don't say gay bill say?
I'm pretty sure that if you find out that someone is gay, you like have to report it to their
So it just
No, it's like if a student confines in a teacher and a parent of that student asks the teacher, did my student say, did my daughter or son say this or this? The parent, the teacher is compelled, like they're obligated to tell the parent.
Okay, don't tell me if you're gay. I don't care. I don't want more paperwork for me. I thought you just said you cannot say gay. I was like, oh, that's stupid. Okay, thank you for educating me. I actually don't read those bills, but I just hear about it all the time. I'm like, okay, I don't know what that means. But anyway, so
But like even with this stuff, like the same things happen.
let's look at this graph though. Do you see that do you see that horizontal asymptote at 2/5? If I graph 2/5, see this dotted line? Right? Do you see this dotted line? And that they never reach that value, which is 2/5. And also on the other side, from the left side, it's also 2/5. Do you see that? So there is horizontal asymptote. But there's a slight problem. Can you tell me what the slight problem is? Yes, George.
It crossed it.
It crossed it, right? We're gonna come back to that. Choose version. Okay. So anyway, so we're gonna come back to that. What is a horizontal asymptote? So if I ever ask you what is horizontal asymptote, find horizontal asymptote. I know my handwriting is really bad. Horizontal asymptote. How do you find horizontal asymptote? In terms of calculus, just do limits x approach infinity on the function. If you reach infinity, it's going to give you a value. And that value is going to be your horizontal asymptote. Not only you had to do that, you had to do it to the left side as well, which is x approaching negative infinity of f of x is equal to L.
Wait, could you repeat really what you just said?
Okay, you take the function reach infinity. You're going to find out where the horizontal asymptote is because it's going to give you a value. For example, it gives you a value here 2/5. on both sides. Therefore, horizontal asymptote is 2/5. So you just have to memorize this. How do I find horizontal asymptote? If I ever ask you, just take the function reach infinity. Even though I didn't ask you limits, I just want you to limit x approach infinity.
What if you get two different answers? Would that ever happen?
Yes, it would, but we're going to talk about that. Okay. But right now, let's talk about this. Now, some people, the clearest understanding, most of people got used to asymptote is vertical asymptote. Vertical asymptote, when did the vertical asymptote happen? So remember, I'm going to recall it. Vertical asymptote happened where? Vertical asymptote is not when denominator equal to 0. It's when after you cancel, right? If you have something cancel, right? After you cancel, if you factor it, and then after you cancel, whatever remain denominator. Because sometimes you have something you can cancel, right? Remain denominator equal to 0. Set the remaining denominator. Look at the last question. Look at the cosine question. Was cosine of x, 2 cosine of x plus 1 and cosine of x equal to -1/2, and we said that equal to 0, so that's equal to 2 pi over 3, and that was the question. So there's a vertical asymptote. Now, if you look at this graph, it's really confusing because if you see any type of vertical asymptote, so for example, 1/x, right? That x can never equal to 0. They will never touch 0. It doesn't matter how low you get, right? But the problem is horizontal asymptote, they don't behave the same way. So I'm going to give very controversial comments, and hopefully nobody get offended. Don't tell me if you're gay or not. I don't really care. That's your life. Because I don't want more paperwork. Okay? So the way I kind of think about it, vertical asymptote, it's like you're for sure gay. You'll never cross that line. You're born to be gay. You are for sure you're not going to cross that line. Horizontal asymptote is like, maybe. I'm going to be bi for a little bit, and then I'm going to turn to gay. So they are experimenting, whether they experimenting man or woman or whatever, and they experiment once, and they say, no, that's not for me. I'm gay. So what am I trying to say is, when limit x approaches infinity, you only care about what happened in the end. They are like an undecided gay. They're not for sure gay. Like a horizontal asymptote is like they sometimes can cross the asymptote. It can cross that. Okay, but it goes to infinite. When the time as it goes to infinite, you are not going to touch. Okay, just what happened later on. Usually you decide whether you are gay or lesbian. I don't really care. That's your life. But does that make sense? Really awful analogy. I know.
No, I don't get it.
What? Okay. So
Just give it to me straightforward. What touches and what does not touch? Like vertical asymptotes, like you don't touch.
vertical asymptote is like for sure gay. You do not touch it at all.
And then
They will never cross that vertical asymptote. Horizontal asymptote, you may or may not. Sometimes you can touch in the middle ground because the definition of horizontal asymptote is limit as x approach infinity. They don't happen, they don't care about what happened you're between 10 and 30. They only care about what happened at the end. Are you a gay or not? Does that make sense? So you can, between 12 and 30, you can experiment whatever it is. So that's just my analogy. I don't know. Sue me if you will. Don't really care. Huh? What do you mean? It just looked like that. They can cross x-axis. Sometimes they tell the asymptote you cannot cross x-axis, but it's not true. Horizontal asymptote you can cross x-axis. You can cross that horizontal asymptote. Vertical you never. Yes. Vertical is like I'm gay. I don't care what you say, but I'm gay. I'm born to be gay. And you have that flamboyant attitude, right? Which is that's your life. Really come here. Anyway, hopefully I didn't offend gay people here. Huh? It's a lot of emails. Don't look at my email. I had to buy extra storage from Google. That's how bad it is. I don't read them. I don't even read them. That's the thing. A lot of email. I don't read them. Okay. Anyway, when you get old, you understand. Okay, that was fun.
You do, right?
Yeah. Then this is just easy stuff.
No, I know how to access it now. You have to complete it.
But Emoto soon's gonna be done, so we're gonna have to find out a way. Can Canvas go back to watch your old homework? Can. I need to figure out a user by today.
Honestly, I think yeah.
Sorry about that horrible analogy.
I don't know. It was fun. I had a good lesson.
Huh?
It was a fun time. I had a good lesson.
I don't know. I just want to make class fun. I don't want a class boring. This calculus can be boring, right? Right, Devin?
I take it, man.
It's what?
Very boring.
Oh.
Yeah, I was wondering, is each question worth 6 points?
Yes.
So how do I get 4?
Oh no, it's not good.
Because you distribute it and you're supposed to plug in 5, but you did not distribute a 2 to 5. It's supposed to be 10. Yes, please. Yes, please. Yeah, but you should like remember that day I asked you. You said, "Oh yeah, it's due tonight." I said, "No, you have to do it." I just said the wrong time. Yeah.
I just looked up the due date and I assumed.
Okay. No, it's always the next day morning. Okay.
After school tomorrow.
Okay.
It's like still.
You can come at lunch too if you want. You can come at lunch. I don't really care, but just bring lunch. Get a lunch and come back in here. You want me to write your pass? I'll write your pass. You want to do that? I don't know. It's up to you. I don't not force you to be here. Okay. All right.
Thank you.
All right, bye. Why? Oh yeah, that was a horrible test you guys did.
I have a joke for you.
I have a joke for you too.
I'll go first. I think mine is not good.
Okay.
Not
Who's there?
Kane.
Thank cool.
Oh, you're welcome.
That's pretty good.
I don't get it.
It matches the race, so it's even what? Like,
I don't get it.
Thank you.
you,
Thank
like, it's like,
Thank
kangaroo,
you.
it's just like, it sounds like a really bad accent, but like, thank you.
you.
It's kind of racist, you know?
But
I know.
understand.
I know. I found the cheapest concert. It only costs 45 cents.
Yeah, 50 Cent featuring Nickelback.
What? 50. I thought that was good. That was good. 50 cents in Victor Nickelback. That's great. You just get it now after like.
It's so crazy how you laugh at your own jokes. Like, I don't know how you can do that.
Because he has confidence. You don't laugh at your jokes, did you?
No, it's like,
If you don't laugh at your own jokes, then it's not funny.
Yeah, who's gonna laugh at your joke if you're
you
not
don't
laughing
laugh
at your own
at
joke?
jokes, if you don't find your joke funny, then who else is gonna
wait,
find
why
it?
is everyone always gonna attack me?
It's wrong. Because your opinion is wrong.
See, they can differentiate what's right and wrong.
I'm being attacked right now.
And yeah, we can't differentiate from.
Yeah.
We have a voice. Yes. Yeah. Yeah, but like not full white. Oh my.
I did my test revisions.
No, you go through it here.
I did it with phone, with tutor.
Faster.
Then we went over related rates and we went over this. We didn't go over the test, but she reviewed stuff with me. I don't have time after school, so I did it with her.
What?
I don't have time after school, so I did it with her. Because I have guard. Want me to leave it here?
Okay, so it made me very. Yeah, the president and vice presidents. I'm trying to talk. Thank you. All right. So, I try to not to look at your tests over the weekend because you might ruin mine. That's basically how bad it was. Yes. Okay. Okay. The only people that I will say that I'm just gonna skim through. RJ, okay, that's an A. Not an A, but it was like with the curve and everything. Zach is an A. Katie is bad. Kevin is pretty good. Kevin is pretty good. It's pretty good. Sarah is not good enough. Samuel, that's pretty bad. Harmon, that's pretty bad. No, shh. Guys. Whitney, that's pretty bad. Sarah Jung, that's pretty bad. Sydney, that's pretty bad. Basil, that's pretty good. Pretty good. Not great, but it's pretty good. It's better than Russian. Oh, that's Paige, that's not very good. Sergio, that's
Come on.
no, that's a halfway back. That's respectable. Paris, that's okay. Asim. Asim, this is not good enough.
Because he's brown, isn't it?
Yeah. Joshua, this is not in your standard now. That's a below your standard. Cheating. Cheating, that's a below your standard. Well, that's the highest probably you could do. With how much Jinju. Jinju is. Jinju is okay. No. Tyson, that was okay. Guys, the power. Was decent. I mean, decent. That's it. Sheila, that's awful. Jordan. Jordan knows what he's doing. Oh. Arian's better than Sheila. Oh.
Wait, actually, I can't.
Yeah, you're better.
So is that like?
That's like you can be on math team. Jackie is not good. Okay, that's it. Did anybody go through? Okay, so the overall is pretty awful. Overall, it's pretty awful, but luckily, you are not gonna see too much of that. But you're great. I'll probably finish grading today, but just kind of give you a status of your test. Now I might be wrong because some of you guys are just planning bad. But there's some people who really did put work. I would say the people who put in work, Zach and RJ, and the Miriam and Basil and Kevin put in a very good work. Katie is awful. Katie definitely didn't live up to standards. Darby, to be granted that she didn't have the paper the first 20 minutes. So she's kind of have things. Okay, so anybody wondering what you did? Okay. So with a related rate optimization, I'm gonna post the people who did good don't need to do anything. I would say RJ and the Zach don't need to do anything tonight. The people who did bad, then you got homework to do. So homework will be posted. Homework is gonna be on this test. I'm gonna post the exact same test, and you're gonna find out what you did wrong over tonight. Now I would say the only two people don't have to do it are Zach and the RJ, because they actually put in a lot of work that I have very high respect of, and that's why I give him 5 points on their previous test, because they are only person that trying to find out the cause, and even though after class, and they trying to find out what the cost of the box is, and they did it. So I give him 5 points on top of that. But I think a lot of you guys are lacking the the attitude that you have last year is because you are just senior or the senior writers or you have too much shit going on. I understand, but please do a better job because like Joshua and Sheila, that was not expected to this low far as you guys. And I'm just gonna be very blunt because you know me already. I'm usually tell you the truth. I hate to tell you lies, but some of you guys are really doesn't live up to the standards. Can you get back to normal? Please do. I wish you do. You know, some of you guys can improve a whole lot better than give me that like barely can get 2 questions correct, then that's bad. Okay, barely 3 questions correct, that's bad. Yeah, so the things about it, are you still have the same mentality? Try to do the best you can. I know that for fact this class does not. And as simple as that. You do not have the same work ethic or same attitude or same things. Now you're gonna have to do the homework, and that's the name I mentioned. Don't have to do it. The homework is gonna be this test. Okay, you're gonna have to go back to understand every detail about that test, every single part of details, and you're gonna have to back to figure out how to do everything. But those are the people I said probably don't need to do, or RJ and Zach. And the rest of you guys probably had to redo it. Basil is very close. Basil's very close. Basil was very, very close. Yeah, Basil don't have to do it. He's white. That's good. Wait, all the white people. Wait, I only mentioned all the white people. I must be racist.
You hate me.
Oh yeah.
Yeah, but someone person
Miriam don't have to do it either.
The token.
Wait, so, but I didn't learn how many questions did I get right?
You did better than Sheila. That's all you need to know.
Do I get
I will pass it back
is
tomorrow.
it anything?
I don't care. All right, so shh. We're gonna go through application of derivatives, and we're gonna go through fast, and you guys gonna have pretty much a review, and then whatever. It should be an easier test compared to any other test. I don't know when's the test yet. Cannot tell you yet. Cannot tell you yet. All right, shh. It's not tomorrow. Don't worry. Surprise! Tomorrow.
Oh. Don't hurt me.
Okay, so we're basically gonna fly through chapter 3, and then we're gonna chapter 4. Shh. Okay, what are the applications that you have to worry about for the coming up things? First of all, we're gonna start at 3.1, which is extremas. You want to find extrema, you want to find critical points, you want to be able to. Okay, let's start with the top. The function must have. So what is extreme value theorem? So we're going to talk about that. Make sure you guys review that. The extreme value theorem. This is a one thing that usually that people forget. Extreme value theorem. What is extreme value theorem? F has to be continuous between interval A and B. So it has to be continuous. That's the only thing it requires. That's the only thing it requires. Result is this. It must have minimum value, minimum, and maximum. Now, why do they say it has to be a continuous in the open interval. So for example, you can have a function in couple cases that just say if I have something like this, open circle between A and B, there is no maximum. There is no maximum because the highest point, you don't know how high it goes. It might be, let's say 1, 2, 3, 4, maybe very close to 5, but how close is it? We don't know. There's no maximum, right? There's no maximum in this case. So it has to be continuous between closed interval. Cannot be the open interval. It cannot be this too. It cannot be like this. There is no minimum here. There's no minimum here, and there's no max. So therefore, it has to have a minimum maximum value if it's continuous through the whole way. It means no vertical asymptote, no jumps, no nothing. Okay. So that is the first thing. How to find critical value? Do you guys know how to find a critical value? Derivative equal to 0. Good. But there's more to that. No. People usually forget the second part. No, not double derivative. No. Yes.
I guess, but is it when the derivative is undefined?
Oh, very good. So it can be f prime of x equal to 0 and the f prime of x equal to undefined. So critical value could be undefined, especially a cusp. Cusp is x to the 2/3 power, and that x equal to 0 is not really defined because you take a derivative of x to the 2/3. So I will just give you a very simple example here. Let's just say f of x equal to x to the 2/3. That's a cusp at 0. So if prime of x is equal to what? 2/3 x to the negative 1/3. So that's equal to 2 over 3x to the 3rd roots. Like this. Okay, to the 3rd roots. So if bottom equal to 0 is undefined. But if x equal to 0 is undefined, it's also a critical number. Because in that particular case, you have a vertical tangent. You have a vertical tangent. Do you guys remember that?
Isn't it all even over R?
When they have a cusp, it's even over R. Even over R power, that's when you have a cusp. And when you have a cusp, then you have derivative does not exist. So you can have not only f prime of x equal to 0, also f prime of x equal to undefined. Those are the things that you had to be careful. So sometimes like people usually forget that about undefined, and they are one thing I will probably talk over is this particular questions is, but we're gonna talk about before that. How do you find extrema within intervals? Find extrema within intervals. First, you must find critical number. Which is, remember, a critical number including two things. Derivative equal to 0 or derivative equal to does not exist. Second thing, what do? Check the endpoint. Okay, so that means evaluate two things. Evaluate critical number, that's the first thing. And RJ says evaluate endpoint as well. Because you don't know endpoints are higher or lower. You must check the endpoint. You already know that from the last year, you always plug in the endpoint and you plug in the critical number and you compare which one's the highest and which one's lowest. The fourth step is you're gonna compare, right? So you're gonna compare. So you want to find this. I'm gonna give you guys a question to ask. Is I want you to find the absolute min and absolute max in this case. F of x equal to 2x minus 3x to the 2/3. And between -1 and 3, I want you to find out where's the minimum value and where's the maximum value. X to the 2/3. 2x minus 3x to the 2/3. Be careful with this question. Let's ask first. How many critical value are here? Darby? Two is good. If you find out one, that means you did not take account into the thing. What happened? If I take a derivative here, I'm gonna get 2 minus 3 times 2/3 times x to the -1/3, right? So that 3 cancel out would be 2 minus x to the -1/3. Now, what I'm gonna do is I'm gonna factor out. Oh, 2, my bad. Okay, so I'm gonna factor out x to the -1/3. What will happen here? I can factor out 2 too. Okay. What else I can get?
Can't you just back up? What?
So wait, you're just like.
What happened if you factor out -1/3? Here, let's not factor out 1/3. Let's just do this. Let's just do 2 minus 2 over x to the 1/3. Does that make sense? I'll multiply this side by x to the 1/3 over x to the 1/3 the same way. So it's gonna be 2x to the 1/3 minus 2 over x to the 1/3. Remember, numerator equal to 0. I'll show you both way. X equal to 1, and also x to the 1/3 equal to 0, x equal to 0. There was two critical points here. Why? There's two critical points. This one is gonna be the undefined one, right? This one is the horizontal tangent one, because it's numerator equal to 0. Denominator equal to 0 usually is the vertical tangent. Numerator equal to 0 is the horizontal tangent. Did that make sense or no? Now I'm going to compare all the value. I'm going to say f of -1, f of 3, f of 1, and f of 0. And I'm going to compare to that. So if I plug in 1 in there, that I'm going to get what? 2 minus 3, that's equal to what? -1? Okay. What's the f of 0? 0. Okay, what's the f of 3? It'll be 6 minus 3 times 3 and 2/3. We have no idea what the value is. We're going to put a pause on that. What happened to -1? No. -2 minus -1 to the 2/3 is going to be +1, right? So that's equal to -5. Now, if you did this, now this part you might have to enter in a calculator to see what is it. If you enter in calculators roughly, I would say, just imagine that this is probably something that, say, a little bit less than 2, I would say. You should end up to be negative 0.24. But then if you compare, which one's going to be... this is what... You can plug in the calculator if you don't believe me. This is the value I got.
No.
You said you were going to show it the other way, where you don't need to talk about it?
You can factor out x to the -1/3,
Yeah.
and you can take out 2. What do you have left in the first case? X to the 1/3 minus 1. Okay, same thing. X to the 1/3 is equal to 1. X equal to 1. X to the -1/3 is equal to 0. This one, no, so x to the, if you flip to the bottom, right? So it'd be x to the 1/3 minus 1 to the 2 over x to the 1/3. You still set bottom equal to 0. Regardless, you're going to get 2. Okay, so shh. Jackie is asking a good question. Jackie, what's your question?
Why can't you just bring the 2 to the other side?
Can you bring the 2 to the other side? Because there is a denominator you have to worry about. Because they are technically, this is what a trap is. The trap is going to have a denominator in this case. And you have to find out what denominator in this case, because you got x to the -1/3. There was a denominator also going to 0 besides the numerator. So what we'll do is actually do this way, and to figure out there's a numerator and this figure out a denominator. If you solve for 1 here, there's only one value, because you're not taking account into the denominator also can equal to 0 as well. Since this is -1/3 power, so it means there's a denominator also. So that's why I said there was 2 critical value instead of 1. If you just set the equal to 0, you're only going to get 1. That's what all the people fall into like this type of trap is because they don't consider denominator as well, because you got negative 1/3 is a denominator. Denominator can equal to 0 as well. That's also critical value. If you plug in the graph, I'll show you what happened to the graph. It's 2x minus what? 3x to the 2/3, right? There is a cusp at 0, and there is a here, and also there was a -2 is going to be -5. So, or -1 is going to be -5, sorry. And -1 is going to be -5. So therefore -5 is the smallest value, and the biggest value is actually 0. But this is still a maximum because it's critical value, which is a vertical tangent here. There's two things happen. There's a vertical tangent and there's a horizontal tangent. Vertical tangent is when derivative denominator equal to 0. Numerator equal to 0 is a horizontal tangent, which has happened right here. Does that make sense? Okay, so there are a few things happen. Even though this is a simple question, everybody will screw up. But luckily they don't test like this. But this is my test, it will test like this.
We should technically divide by any number then. Because it cancels out.
I actually have a legitimate question. What's your question?
Because you divided by x to the 1/3, both in the numerator and the denominator, cancels it out, right?
I didn't divide, I multiply. I multiply here by x to the 1/3 and x to the 1/3.
Yeah, so you can just multiply by any number as long as it cancels out.
Long as it becomes 1.
Yeah.
This is just a technique, right? This is just 1, technically.
So you can do the common denominator. Denominator.
And why do you want to do that?
To combine so that you can factor.
You want to change the factor form so you can solve for zeros.
Then it becomes like then you can look at the so
Why not just add it?
that's why we like
Okay, shh. I want you to find minimum value and maximum value here. Remember, value is what? YU, right? So, if I ask you minimum value, it's going to be Y value. You had to plug in whatever critical number you had to compare. So, what happened if I have trigonometry? Same operation. There's no different things. It's going to be same operation. You have to worry about same operation. That there's nothing complex. Two sine of x minus cosine 2x. I didn't say nothing.
I heard.
Let's go.
Katie, get to work. You finished?
The range.
White people are weird.
White people, that's true.
Is there one? You don't know if there's one.
Sergio, you finished? Now without paper and pencil. You figure out yet?
You don't know the right way.
There's no undefined in this case. Will, get it done. Sergio, get it done. You done? How about minimum? Sergio, I'm going to ask you to leave.
That's it? There's more. Side two.
What?
What gets you out of that? You remember when doubling sine 2x is equal to 2 sine x Oh, what did you put it? Why it's oh god. It's and what's he doing? I originally looked at the accent and didn't all three. No, there are. Oh, wait, yes. And then I can I can do that. Yeah, today. I'm so proud of it. And then multiply. Wait, how did you get here? How did we get here? Yeah, I figured it out. That one, yeah, I mean, you could factor. I was just calculating cosine 2x minus
Okay. Minimum is a 93/2. It occur at 7 pi over 6 and 11 pi over 6. Maximum occur at pi over 2, which is equal to 3. This whole question tests the whole trigonometry ideas.
Did you have 7 pi? Or did you have 7 pi? That's what I had before.
No, you're good.
I know.
You need to plug it in.
Minimum is a negative. Is that 7 pi over 6? Value is a negative 3 over 2. Yeah, it tries at 7 pi over 6 and 11 pi over 6. All right. So we deal with finding critical value. We deal with finding extremas, which is absolute maximum value or absolute minimum value. So you have to compare the endpoints. The derivative, you should know your double angle identities. You supposed know them. You should not supposed to ask me like Miriam asked me. What is the way? I don't know. You are the one that's supposed to know because I test you before. Whatever I tested before is to take account for. That is the first part. Now, let's go to the next. We're going to talk about 3 more theorems. They are pretty easy. Yep, they are rule theorem.
Okay, but did you tell us about that? Continuous.
I cannot talk over you. Rolle's value theorem, they are very easy. First condition is what? It's a continuous closed interval A and B. Second condition, differentiable between A and B. But it's open parenthesis A and B like this. So there is slight difference. The third condition is a main deal breaker. What is the third condition? Was it Cindy? What did you say? Oh, Darby. So Darby, what are you saying? No, almost. F of A equal to F of B. So what I mean by that, Rolle's value theorem, if you have, let's just say, A and B, right? So the result is this. What do you think the result is? F prime C must equal to 0. At least 1C though. At least 1C. At least 1C is equal to 0. Why? I can have, if I have this point or the same, the output are the same, I can go straight. That's infinite amount of C. I can go with this. C happen right here. I can go with this. C happen right here. Right? I can have C1, C2. I have multiple C, but at least 1 C though. Minimum at least 1 C. That's it. So it must have 1 C is equal to 0. Rolle's value theorem. The next one, mean value theorem. You guys know that you cannot forget this one. This one is constantly on AP exam, constant on BC exam, constant on AB exam. Mean value theorem doesn't matter what your exam is you go into. It's always something it's gonna have to be able to deal with it. So mean value theorem says it must be continuous between A and B. Oh, by the way, it cannot including endpoint. Don't including endpoints, okay? Don't including endpoints. If you see it's at N, don't include them. Don't include endpoints. Because they say it's between A and B, so don't including. So the C has to be here, but it's open parenthesis for both. Same thing for mean value theorem. The second condition is must be differentiable. between A and B. So there's f prime of C is equal to f of B minus f of A over B minus A. And C has to be between at least one C. At least one C in the interval between A and B. So remember, not including the endpoint. If you got your C, it end up to be endpoint, it should exclude them. Especially those of you guys are doing competitions. They love to give you a value at an endpoint that you should exclude. They might happen in AP exam as well, but more likely they'll be more reasonable with you, not gonna take account into the endpoint. Now, if you guys are doing a competition, then you have to worry about endpoint just as much as the critical value. Not critical value, but just where the C is equal to f of B minus f of A over B minus A. Now, reason why I will memorize this mean value theorem is this actually two things happen at the same time. One is called instantaneous rate of change. One is called average rate of change. Is where instantaneous equal to average rate of change. I'm gonna write it down instantaneous. Instantaneous is just f prime of the x, right? For average rate of change, it's gonna be f of B minus f of A over B minus A. So there is no difference between mean value theorem and the combination of instantaneous and average rate of change. Mean value theorem just saying it's when instantaneous velocity is equal to average velocity. That's the only time it happens. When the secant line is equal to tangent line. I'll see you guys next time.
I had two questions. I don't have it back. I need some corrections on that. And then also, I did the corrections on the derivative test, the limits test. I just wrote down whether the things that are wrong in the unit so I
When
can
you're doing corrections, do you understand them or you just do it for the sake of the points?
understand. Like, basically, I've been getting with somebody who, like whoever comes to me, whether it's Zach or Katie, whoever's like actually like understanding it and asking questions when I'm trying to do
So I'm gonna trust you that you actually know it. I'm not failing it. I'm not giving people a B or C, but you have to put it in your effort. I don't see that effort yet. I have to see that effort to get a B. I haven't seen it yet. I seen that last year, third, fourth quarter. I don't see that. So right now, it's probably in double C right now, but I need you to improve your things. I don't know, this year you kind of like puzzle me a little bit. I feel like you're being off.
I don't know what that actually no. I wish I knew.
I don't know, it could be in here.
I don't think so. And do you happen to have my algebra test anywhere or no? I didn't have it, so I don't know if it's just.
I probably do, but I'm looking for it.
Okay.
Is that okay? I'll
I'll
give
come
it this
to her
afternoon.
Tuesday because I can't come today in club meetings, so I'll come tomorrow. And
That's fine. In this year, you seem kind of down.
yeah,
What happened?
it's just it's frustrating. It's really
About my class or my other class?
uh
Or mainly in this class?
this class and just like a lot of stuff combined. So
Like
Yeah.
what? All right.